Welcome to our video on how to compare positive and negative numbers. As usual, we'll do curricular outcomes, we'll talk about how to compare the numbers, then we'll dive into our examples. So our curricular outcomes, at least as they are phrased in Alberta's Grade 7 Math, the 2026 draft. Our organizing idea is that numbers are organized into systems with unique notation to communicate quantities and to facilitate calculations. Our guiding question: how can the symmetry of the number line contribute to a sense of number? Our learning outcome: students will analyze positive and negative numbers. And our key understanding for this block: every fraction and decimal number has an additive inverse with the same absolute value and opposite sign. So the additive inverse of 3 is negative 3. The additive inverse of negative 3 is positive 3. Today's skill is comparing and ordering numbers. So we're going to compare and order positive and negative numbers, including decimal numbers and fractions. How do we do this? When we compare two numbers, we generally use one of 5 relations. Relations in math are ways to compare or connect one thing to another. The most common is equality, those two horizontal lines. That's for when two numbers are identical in value. So they don't have to be identical in representation. 1/2 is equal to 0.5, but they have to be identical in value. Less than. The greedy mouth is open to the right to eat the bigger number. This is for when the number on the left is less than that on the right. Greater than. Our greedy mouth is open to the left because the number on the left is greater than that on the right. So it's trying to eat the bigger thing on the left. There are also two combinations of these. There's less than or equal to, which is less than with a single horizontal line under it. That is for when the two numbers are allowed to be equal, but the one on the left is also allowed to be less than the right. These are used in places like budgeting. Push comes to shove, you can spend all your money. Ideally, you're spending less than all your money, having some saved for what they call a rainy day or for emergencies. But you can't spend more money than you have access to. Greater than or equal to. That's where the greedy mouth is pointed to the left. The two numbers may be equal, or the left may be greater than the right. Good thing to note when we're actually doing the comparisons: all negative numbers are less than all positive numbers. So if you're comparing two numbers and one is positive and the other is negative, the negative is guaranteed to be less. That's just automatic. When comparing two positive numbers, the number closer to 0 is the lesser number. So 1 is less than 5. It's 1 unit away from 0 instead of being 5 units away from 0. When comparing two negative numbers, the number closer to 0 is the greater number. -1 is greater than -5. If you add 5 units to -5, you just barely make it to 0. You add 5 units to -1, you come all the way up to +4. +4 is greater than 0. Both of those numbers were shifted the same 5 units in the same direction. So with negative numbers, the number closer to 0 is the greater one. Comparing decimals. When comparing two decimal numbers with the same sign, the first thing we want to do is make sure they have the same number of digits after the decimal place. If they don't match, you add zeros to the one with fewer digits until they do. That just helps our brains wrap ourselves around it. So if you're comparing 1/2 and 1/8, converted to decimals, you want to compare 0.125 to 0.500, not just to 0.5. Otherwise, we can go, oh, 5 is less than 125, but the position matters. 500 is clearly more than 125. Once the decimal places match, you start from the far left and compare digit by digit until you've determined which is greater and which is less. So let's compare fractions through decimal conversion. That's one way to do it. When you are comparing two fractions, there are multiple options available. One option is to convert fractions into decimals and then use our existing method from the previous slide. For example, which is greater, 13 over 16 or 19 over 24? Well, if we turn 13 over 16 into a decimal, we get 0.8125. If we turn 19 over 24 into a decimal, we get 0.791, and then that 6 starts repeating. Converting into decimals, 8 is greater than 7. That top number is greater than the bottom number, so 13 over 16 is greater than 19 over 24. When you're converting to decimals, this method is greatly preferred when you have fractions and decimals being compared to each other. If you just turn everything into decimals, it's much easier. Now, when you have two fractions, sometimes it's easier to compare them through common denominators. So if you could take two fractions and put them over a common denominator, sometimes by reducing them if they're not already in lowest terms, then this makes comparing them as simple as comparing their numerators. Comparing fifths to fifths is like comparing meters to meters. You can now just compare the other numbers. For example, which is greater, negative 7 over 12 or negative 8 over 15? Well, what is our common denominator here? We've got 12 is 3 times 4, 15 is 3 times 5. So we could do common denominators. We count by 12s, count by 15s, make both lists till we find one number on both lists. We find it is 60. What do you multiply 12 by to get 60? Well, you multiply 12 by 5, you multiply 15 by 4. We're not trying to change the value of the fractions. We're just trying to write them in a way that's easier to compare. So that means we have to multiply by 1. That doesn't change it. So that's 5 over 5 and 4 over 4. These are the fractions we use. That's why whatever we do to the top, we do to the bottom. We're not trying to change the value. If we multiply by a fraction equal to 1, we have a more convenient way to write the number, but it's still the same number. 5 times 7 is 35. 4 times 8 is 32. Well, negative 32 is closer to 0 than negative 35. So that makes negative 8 over 15 greater than negative 7 over 12. Remember, we're dealing with negative numbers. If we had positive numbers, well then 7 over 12 would be greater than 8 over 15, because 35 is greater than 32. With negatives, the negative 32 is greater than the negative 35 because it is closer to 0. Let's look at some more examples. Which is the lesser number, 57 over 113 or 221 over 441? Well, here the number 113 is prime. So putting them over a common denominator is going to get difficult to work with because we're going to end up with 113 times 441 as our common denominator. We're dealing with 6-digit numbers. So instead, decimal representation will be easier. We may not get all the way to the repeating decimals. We just have to go far enough to recognize which is greater. Especially since with a denominator of 113, in theory, you could have to go as many as 112 digits in before anything starts to repeat. So how do we write 57 over 113 as a decimal? 57 divided by 113 and 221 divided by 441. Our first fraction is 0.5044, so on and so forth. I've got the 3 dots here because it's not repeating yet. We don't have that identical pattern. Similarly, the 221 over 441, that does not have the identical pattern, so we just ended in 3 dots to say the number keeps going. Now we go left to right until we find the first digit that is different. So 0.50, and there it is. 504 versus 501. So 4 is greater than 1. So 0.504 is greater than 0.501. So 57 over 113 is greater than 221 over 441. Right? Our lesser number is that 221. Now, let's do some together. Verify that. So here they're saying, we think this is true. Prove it. We want to prove that 91 over 98 is less than or equal to 65 over 70. In this case, a common denominator approach is going to turn out to be the simplest approach. We start by putting both fractions into lowest terms. Right? Our 65 over 70 clearly has a common factor of 5. 91 over 98 also has a common factor. In this case, it's 7. We pull the 7 out of the numerator and denominator. The 7's cancel, and it reduces to 13 over 14. Our 65 over 70, we pull out a common factor of 5. We have 13 times 5 over 14 times 5. The 5's cancel, we're left with 13 over 4. So these are both 13 over 4 in lowest terms. The two fractions are equal. So now, it is true that 91 over 98 is less than or equal to 65 over 70 because both are equal. One is not less than the other. Be careful. This works because it's less than or equal to. If we didn't have that or equal to option, this would be false because these are not allowed to be equal. If we don't have that horizontal line under the less than, being equal is not a solution. It does not satisfy that relation. So 91 over 98 less than 65 over 70, that's false. It's not the case. All right, here are some examples for you. So we'll fill in the blanks with less than, equal to, or greater than. Our first one, 12 over 37 compared to negative 100.1237. We're comparing a positive to a negative. So the fraction is greater than the decimal because the fraction is positive, our decimal number is negative. Our next one, 27 over 73 minus 32 over 89. These are two relatively large prime number denominators, at least large compared to the numbers we're used to, tiny compared to any number we've ever named. Now, if we take these two, 27 over 73 is about 0.36986, so forth. 32 over 89 is more like 0.35955. We compare the digits here. 6 is greater than 5 in our hundredths place. So 27 over 73 is greater than 32 over 89. Our last one, 6 and 4 are relatively small denominators. Both numbers are negative. We'll compare these with the common denominator method. So the common denominator, or at least the least common denominator of 6 and 4 is 12. So negative 5 over 6 is the same as negative 10 over 12. We multiply top and bottom by 2. Our second fraction, if we multiply top and bottom by 3, we'll get that denominator 12. So that's a negative 9 over 12. Now the negative 5 over 6 is then less than negative 3 over 4 because they are negative, and because 9 over 12 is closer to 0 than 10 out of 12. 9 is closer to 0 than 10. If you have any questions or any feedback, please leave a comment. I promise I will do what I can to respond in a timely fashion. I would really love the feedback because I am building these as lessons to teach a course that's being taught for the first time in the very near future.